Okay, here's our exponent rules notes. So this is learning target 1.c. So our third kind of category of learning targets. To get started, you do now is to just fill in this table as best as you can. So these are all of our most important exponent rules. So I've listed the names of the rules. Directions means what do you do, like what happens when the rule is applied. And then I have an example here to kind of help you as well as show you what those rules are. So what I'd like you to do first, just pause this video, copy down this table, and then fill it in as best as you can. Okay, so hopefully you've had enough time. If not, pause it again. So with these rules, they're all rules that you've seen before in Algebra 2, but we're bringing them back. We're seeing them again here in pre-calc. So the product rule. The product rule is when you have, let's make sure we can see those. Okay, product rule. So with the product rule, that is when you have two like bases with exponents and they're multiplied together. So when you're multiplying the same variable, remember you add exponents. That's the product rule. So a to the fourth times a to the fifth, you add the exponents. 4 plus 5 would be 9, so that would be a to the ninth. The power of a power rule is when you have a base or a variable, a number, to a power to another power. So this is b to the third to the fourth, so we multiply those together. So 3 times 4 would give us 12. So when you have a power of a power, you multiply exponents. Next is the zero exponent rule, something to the power of 0. Anything to the power of 0 just equals 1. Second to last here, the quotient rule. So this is when you are dividing the same base with exponents. So when you're dividing, so we have d to the 7th and d to the 4th. So when you're dividing, you subtract exponents. So 7 minus 4 is 3, so we get d to the third. Next we have negative exponents. Anytime you have a negative exponent, you bring it to the other side of the fraction. So e to the negative 2 is the same thing as 1 over e to the power of positive 2. So we could say move to other side of fraction and exponent becomes positive. So whenever you have a negative exponent, you move it to the other side of the fraction, so from the top to the bottom or the bottom to the top, the exponent becomes positive. So these are our 1, 2, 3, 4, 5 exponent rules, which will all come in handy as we're doing some practice here with exponents. So let's continue here. So let's zoom in. So we're simplifying exponents here. So number 1, we've got k to the 5th to the 4th times a to the 5th times k squared. So I see a power of a power rule here. So with a power of a power, you multiply those exponents. So 5 times 5 would be, or 5 times 4 would be 20. So we have k to the 20th times a to the 5th times k squared. You can put the time symbols in between if you want to, but anything put right next to each other we just know as times. Next, we have a product rule because we have k to the 20th and k squared, so we add those exponents. So we'll just have a to the 5th and k squared. So it's important that you have all those rules that we wrote down up here, all those rules written down so that you can refer to them. Okay, now number 2. So we have x to the 3rd times a to the 3rd times x squared to the 5th. So notice now we have in parentheses both a cubed and x squared. So even though these are in parentheses and there's a multiplication symbol, this isn't like a FOIL type scenario. If there were addition or subtraction, it would be, where you'd have to repeat like a cubed plus x squared times a cubed plus x squared times a cubed plus x squared and so on, and then you'd have to do all that foiling stuff. But since it's all multiplied, all you do is you just apply this power of a power. So a to the third to the fifth means you multiply that 3 and 5, so we get a to the 15th. X squared to the fifth means you multiply that 2 and 5, so you get x to the 10th. Next here, we are adding exponents. We've got product rule here. So x to the third and x to the 10th gives us x to the 13th. So I have a to the 15th, x to the 13th. Notice as with the last problem, you can't combine the a and x. They're different variables. You can only add those exponents when they're the same variable. Okay. All right, moving on. Okay, so we've got 4 multiplied variables here. When we're simplifying, negative exponents are not something that we want. So we want only positive exponents. So let's just start here by shifting that p to the negative 3 down to the bottom as p to the third. So we don't like negative exponents. Next, again, we've got a product of a product rule because we have 2 r terms, r to the 5th and 4th. So we just add those exponents together. And there we have it. Okay, moving on, number 4. And as we're going through, if you want to pause the video to write down these problems, you're welcome to do that. I know I'm going kind of fast. We have a to the 5th, b to the 3rd, c to the power of 0, and b to the 7th. So I notice we have something to the power of 0. That's just 1. Next we have b to the 3rd and b to the 7th being multiplied, so we add those exponents. So we've got 3 plus 7 is 10, so we have a to the 5th, b to the 10th, times 1. You just don't need to write a 1 because it's multiplied. And we're all set there. Okay. All right, so there's your first 4 problems. So what I'll have you do, pause the video here, go through those next 4 so you can write each of those down. If you can see it, pause it, write those down. I'm going to zoom in for those that maybe can't. Okay, so there's 5 and 6. Pause it, write the problems down. Okay, and then 7 and 8. Pause it, write the problems down. Okay. So I won't go through these with you here, but you should get 12d to the 19th, a to the 28th, c to the 15th, 4, 7, and 8. You should get z to the 29th, c to the 12th, and you can have it in either order. And lastly, x to the 5th over c squared. Okay. So check those, make sure you got all those correct. Okay, and let's move on. So here we go. We've got 2 new types of problems here. Now there's a lot more going on. We've got fractions now. So as you're going through these problems, kind of the best way to go about them is to simplify the top, simplify the bottom, and then if there's anything you can cancel, go for it from there. So in other words, usually the steps that we would take here would be, let's start with power of a power. So for a, the only power of a power here we have is this k to the 15th, because we have 5 times 3. So exponent to exponent is power to power. So we get k to the 15th, a to the 5th, k squared. No powers on the bottom, so we'll leave that as is. Next, if we've got like a product rule, usually that's where we would go next. So you just check the top, check the bottom separately. So on the top, I notice we have two terms, or two pieces here with k, so we have k to the 15th and k squared. So we can add those exponents together by the product rule. So we get k to the 17th, a to the 5th, and then a to the 3rd, k to the 5th. Last thing we do is the quotient rule. So that's our division. So let's just start with the a's. So we have 5 a's up top, 3 down below. So we can subtract those. 5 minus 3 is 2. So we've got a squared up top. Then we've got 17 k's up top, 5 down below. 17 minus 5 is 12. So we have k to the 12th. And that would be our solution. Whatever variable is larger, whether it's on the top or bottom, that's where you should end up. So if this were 5 on top and 17 on bottom, then that k to the 12th would stay on the bottom. So make sure, it's kind of like what you're doing is you're taking away 5 k's from the bottom and 5 from the top. It's like canceling. That's what that quotient rule is. Okay, let's look at one more. So we'll start with that product rule. If you want to pause it and write down this problem, you're welcome to. So we have x to the 6th to the 3rd, so 6 times 3 is 18. No more power of a power rules up top. Down below, 5 squared is x to the 10th. So we are all set there. Next, if we have any product rule, that's where we complete those, but on the top and bottom, so xyz, no duplicates, so we move straight into that quotient rule. So for our x terms, we have 18x's up top, 10 below. 18 minus 10 is 8, and the 18 is larger than 10, so that x stays on the top. For our y's, we have 5 and 9. Well, 9 is larger on the bottom. 9 minus 5 is 4, so we've got y to the 4th. And then we have z squared and z squared, and z squared. So those end up canceling out because 2 minus 2 is 0. So we just have x to the 8th, y to the 4th. Okay. All right, and let's get a little bit more practice here with some of these problems. Okay. Hopefully that's visible enough. No, I feel like I made it worse. Okay. So go ahead, write down those problems. Pause the video when it's in focus, like now. We'll just go through these 4 here. Okay. So as we look at number 2, we've got x to the 6th to the power of 0. So we've got that power of a power rule. So 6 times 0 is 0. And we know x to the 0 is just 1, so that's going to end up canceling. Down below, we don't have any of those power of a power rules. So that x to the 0 cancels. Next, look for product rules. So we have 2 y's up top, y to the 5th and 9th, so we can add those together. 5 plus 9 is 14. Don't have any more x's. But on the bottom, we got x to the 5th, y to the 7th, and z to the 5th. From there, we want to use that quotient rule. We only have a y on top and bottom, so those are the only ones we can worry about. 14 is larger than 7, so we know our y's are going to stay on the top. 14 minus 7 is 7, so we've got y to the 7th over x to the 5th, z to the 5th. Let's move down here to number 5.
So for number 5, we've got another power of a power rule here. X to the 6th squared. 6 times 2 is 12. And if you can do some of these rules in the same steps, that's totally fine. It's all up to you. Next, we do our product rule. So 4 plus 9 gives us y to the 13th. So again, product rule only applies if it's the same variable. And then lastly, our quotient rule. 12 minus 3 is 9, 13 minus 2 is 11, and we've got that z to the 5th down below.
So we're all set there. Okay. All right, just 2 more here.
So for number 3, up top we have x to the 6th y squared. So since they're multiplied, we're just going to kind of distribute in a way that 3 to each. So 6 times 3 is 18. 2 times 3 is 6. And then down below, x to the 5th squared. 5 times 2 is 10. And then we've got that y to the negative 4. So negative 4, remember, whenever you got a negative exponent, we don't like that. So what we're going to do is we're going to bring that up top here. So we have y to the 6th. We're going to bring that y to the positive 4 now up top, over x to the 10th. We've got a product rule here with y's, and we have a quotient rule with our x's. 18 minus 10 is just 8. So over 1, or anything over 1 is just itself. So x to the 8th, y to the 10th. Last one here, x to the 6th y squared, all to the power of 0. So anything to the power of 0 is just going to be 1. So we don't have to worry about that, which is nice. So we just have that x to the 9th up top. If that x to the 9th didn't exist,
All you would have would just be a 1 on top.
we have 2 times 3 here for our x's, so x to the 6th. And then we have y to the negative 6. So let's bring that y up top. And then we've got a quotient rule with our x's. 9 minus 6 is 3. So we have x to the 3rd, y to the 6th.
Okay. All right, we're almost done here. Last thing I want to do here is just talk about some fraction exponents and some negative exponents. So remember, whenever you have a rational exponent, it's a fraction. So like here we have 7 to the power of 1 over 2. It's always if you're writing it as a radical, it's always written as power over root. So in this sense here, for 7 over 2, it would mean we have a power of 1 and a root of 2. And a root of 2, remember, is just a square root. So it'd be the square root of 7 to the 1st, or just 7 to the 1st. So remember, as you recall hopefully from last year, anything to the power of 1/2 is the same thing as a square root. For number 2 here,
We have 4 to the power of 4 over 3. So it's power. So that 4 is going to be our power. Our root is going to be 3. We have a cube root,
or a third root, to which we could simplify a little bit more. 4 to the power of 4. Well, 4 times 4 is 16, times 4 is 64, times 4 again would be 256. So we've got the cube root of 256. And you could see if there's anything that multiplies by itself 3 times to get to 256, and you could simplify that further. But for the sake of this one, we won't do so. Next, we have 2 to the power of 5 over 3. So power over root, so 2 to the 5th over the cube root. Okay. So just power over root. You've got 3 more problems here, so go ahead and try those. We've got 7 to the 4th over 3, 6 to the power of 3 over 2, and then lastly, 2 to the power of 1 over 6. So go ahead, pause it, quick do those.
Okay, so power over root, so it'd be 7 to the 4th over the cube root. Power over root, it'd be 6 to the third over the square root.
And lastly, power over root, it'd be 2 to the first and a sixth root. Okay. All right, so we've done a little bit with negative exponents. Just to kind of review real quick, negative exponents, remember, always move to the opposite side of the fraction. So if it's on the top, move it to the bottom. If it's on the bottom, move it to the top. And then change the exponent to negative. Negative exponents are some of the more challenging ones. So we revisit here just to make sure we've got that stuff down. So I don't want to go too long here, so we're just going to pick a couple problems from this one. So let's look at, here we go, 6, 7, and 8. So number 6, we've got 2n to the negative 2 over 3p to the negative 3. So that 2 and 3, those are separate. They're multiplied, but they don't have negative exponents attached. So those don't switch sides. Only the variables do. So this n to the negative 2 will get shifted to the bottom as n squared. This p to the negative 3 will get shifted to the top as p to the third. So so only the part with the negative exponent gets shifted. So be careful with that. So negative 7, again, only the parts with the negative exponent get shifted. So like this x stays where it is, the 9 stays where it is, but the y and z, those have got to get shifted. So y to the negative 1 will get shifted down to y to the first, which you don't need to write 1. Z to the negative 2 will get shifted up to z squared. Okay. Last one here, just to be clear. So anything that doesn't have negative exponents, that stays where it is. So the 4 and the a and the negative 3. But b and c, those have got to shift. So b to the negative 2, we flip down, change to a positive exponent. C to the negative 2, we flip up, change to a positive exponent. Okay. All right. That's all we're going to do for today for our exponent rules notes. I know this is a longer one, but thanks for bearing with me. I hope you all have a great day.